Hi, I'm Gordon, and this is the third video in a short series we're doing on natural language processing. And specifically here, we're taking scouting reports for NHL draft eligible players and reading through them, then using a neural network model to tell us what position that player plays. And we've divided it up into just two options, forward or defender. And in this last video for this project, I want to take a closer look at just a couple of things that I think are interesting and useful. Here I've already obtained some results, and depending on the random state you use, these results will vary a little bit between maybe 92% and about 97% accuracy, depending on how the data is all divided up. For right now, though, I think a useful question to ask when we do a project like this is, which reports did it get wrong? Where did it get tripped up? That's what we're going to take a quick look at here to start. So first thing we're going to do is copy over the results. And it doesn't really matter what we call this. It's going to create an object to point to the results that we got. And I'm going to go ahead and do a couple of real quick things here. Because the results, as they come out, are not actually going to be rounded to whole numbers, we need to round them manually. Okay, and we're going to create a list for the predictions that our model gives us and iterate through the predictions. And this might be hard to visualize without taking a closer look, but this is what we need to get to in order to actually see the results or the predictions. Right. Okay. And which ones did we get wrong? I'm going to create a list to compare the true positions played by the players versus our predictions. Okay. So we want to say if the actual list prediction at that position does not equal what we predicted, we're going to essentially store the index of where that occurred. Okay. Out. And you'll see what this gives us in just a second here. Bear with me. Okay, great. So for every element in our list of the actual positions played, we're going to compare whether that position is mirrored in its prediction. And if it's not equal to that, then we're going to print out information about, which player, what the predicted position was, and what the actual was. And I have a syntax error here. Need to eliminate that dot. There it is. Fantastic. So now we can actually see these are the players that we got wrong. And you can also see what the predicted position was versus what the actual was. It looks like almost all of these were defenders that we predicted were forwards. Now, something that I know about the data is that there are more forwards than defenders. So in some senses, it does make sense that we would skew toward predicting forward rather than defender. Nonetheless, these are incorrect. And here's one where we actually predicted this was a defender, and it was in fact a forward. And we can go through the data that we've got now that we know what was wrong, and find out, maybe read the report even, and find out something about, what went wrong. I'm going to go ahead and pull up one of the reports here that was wrong. This was the forward who we predicted was a defender. And it's interesting to me to just kind of read through these and determine, can I tell, as a human reader, can I tell what position this person plays? So it's talking a lot about points, differentiating skill, physicality, skill. This would be the key to me as a human reader. This says he gets to the net and can finish plays. That sounds like a forward. Interesting, though. It's not made explicit in this report what position the player actually plays. Fascinating. So that's one thing that we can do. Just trying to go through and evaluate how our model did. At the beginning, I also imported the confusion matrix. At the beginning of this project, that is. Report. And we're just going to compare the actual test information to our predicted positions. Combustion matrix. That is not how you spell that. There we go. Here we can get precision and recall information. And as we already saw, right, the way that this model struggles is it struggles in identifying defenders when it sees them. It's very good at identifying forwards. Yeah, all right. I'm going to go ahead and stop this video here. I may do one more at some point just using a different kind of model. Or I might not. We'll see. But based on all of the experiments that I've done, this project really works best with a neural network classifier. Other models can get into the 90s as far as accuracy goes, but there is something the neural network classifier. All right, thanks so much for listening.